Okay, so let's start. So good evening. My name is Andrzej Kamiński, and together with Willie, Ilse, and Shai, I'm co-organizer of this meetup. If you think about the definition of DevOps, it's a combination of culture, automation, lean processes, measurements, and recovery. But the bottom line is, the objective is to deliver systems that address our users' needs. We do it faster with higher quality, and we can maintain those systems. Now, the challenge with modern software delivery is that streamlining delivery workflows becomes tricky as application and infrastructure grow in size and complexity. Now, one of the ways to address that is containerization, and it has many benefits like portability, efficiency, agility, faster delivery, or improved security and easier management. But at the same time, it's a paradox because it introduces complexity, especially in the environments where there are legacy systems. Stateless environment does not really work very well for legacy storage architecture. Storage does not really scale very well with applications, and security as well. So we are lucky today to host Reza Ramezanpour from Tigera, who will talk about Project Calico that is going to sort of address some of those issues. But before we start, a few housekeeping items. First of all, the session is recorded. Please keep your mic muted during the presentation. After presentation, there will be time for questions, so you will be able to unmute yourself and ask the question directly, or you can actually ask the question during the presentation by typing in a chat window. So with this, I would like to invite Alara. Alara, would you like to introduce Tigera and introduce Reza?
Of course. Thank you, Andre, for the introduction and giving us an opportunity to be here. Hi, everyone. My name is Alara. I'm the community manager for Tigera's open source project Calico. Just a bit of a background about Tigera. Tigera is the creator and maintainer of open source project Calico. Calico is the most widely adopted container networking and security solution in the industry. And we power more than 100 million containers across 2 million plus nodes all around the world. I have been with Tigera almost about over 2 years, and I'm located in Vancouver. And I also have my colleague here, Reza, who will be doing the presentation and demo after our intro as well. He is one of our developer advocates at Tigera, and today he will be talking about network policies, going over some of the differences between Kubernetes network policies and Calico network policies. So Reza, I'll leave you the stage. Thank you.
Thank you. Hopefully everyone can hear me. Yes or no?
Yes.
Loud and clear, yes.
Awesome. All right. So let me share my screen. All right. All right. Calico, a brief introduction. Well, by now, I guess you know my name. I'm a developer advocate at Project Calico. I'm a huge fan of testing stuff on live production environments. I usually use an LLL policy to secure my workloads, and I'm always eager to learn new stuff and open to suggestions. So let's connect and exchange ideas. These are the agendas for today's presentation. I'll give you an overview of Project Calico and how Calico does what it does. Then I will go through Kubernetes network policy and try to explain why I think Calico network policies should be used in a cluster. Then I'll talk about shift left, and if everything goes right, I might have a demo to share. If you got any question, as Andre suggested, please type in chat. At the end of my presentation, I'll do my best to answer it. If I don't know the answer, which by my calculation is going to be most of the times, please remind me in Project Calico Slack, and I'll try to connect you with people who know way more than me and can help you with your Calico journey. All right. So what is Project Calico? Project Calico is a community behind a pure layer 3 approach to virtual networking for highly scalable data centers. Calico is an open source networking and network security solution for containers, virtual machines, and native host-based workloads. It is important to note that Calico is not just a Kubernetes CNI. In fact, Calico supports a broad range of platforms, including OpenShift, Mirantis, OpenStack, and bare metal services. Project Calico is an active community about cloud networking and security. So feel free to join our community using these social networking handles and drive the conversation where you see a need for a change or seek help for your Calico adventure from developers who are actively working on the project. All right. So Project Calico offers Calico CNI and Calico Network Policy Enforcer. Calico follows the CNI or Container Networking Interfaces specification. CNI is a cloud-native computing foundation project that consists of specifications and libraries for writing plugins to configure network interfaces in container environments. This allows Calico to be deployed on any software that supports these standards. In the simplest form, Calico will provide network connectivity in the cluster and enforce network security policies. I think mentioning that Calico supports YAML could be a huge hit with our audience, but I don't know. All right, so while it is possible to write policy resources for Kubernetes and add them to cluster, Kubernetes cannot enforce these rules on its own because Kubernetes cluster relies on CNI plugins to enforce such rules. These are the outlines of specifications that a CNI should implement. Sorry. These are the outlines of specifications that a CNI should implement in order to be recognized as a CNI and be used by other softwares. In addition to policy enforcement, Calico provides a variety of other features. Encapsulation, IP address management, and a pluggable data plane are some of these features. Options such as IP tables, VPP, eBPF, and NHS for Windows are the data planes that Calico supports at the moment. Depending on your needs, you can choose any of these options to establish networking for your cluster. For example, in a Linux container environment, Calico eBPF data plane gives you blazing fast networking with a minimum resource utilization by directly injecting BPF programs to drive the networking traffic. There are many other features that are worth exploring, but unfortunately, I have only practiced to present network security policies. On that note, let's continue with Kubernetes network policies then. All right. Network policy is the primary tool for securing a Kubernetes network. It allows you to easily restrict the network traffic in your cluster. So only the traffic that you want is allowed to flow. These policies are delicate resources and they should be precise, or the outcome might cause havoc. Kubernetes network policies are a way to affect namespace networking traffic. These policies can manipulate the behavior of ingress, inbound, or egress, outbound flow of traffic. Policy rules can also specify the traffic that is allowed to or from other pods, namespaces, or classless interdomain routing or CIDRs. In order to write accurate security rules, you need to define the traffic as best as you can. Selectors can help your policies to tighten their grip around different pods. It is important to mention that even if you don't define a namespace in their network policy, it will share the default or current namespace of that context that you have. For instance, if you apply the current network policy that you can see in the picture, after applying the kubectl, the API server will enforce namespace default, which was used by the user as the default context for this policy. All right. Let's see if the demo works. Couple of notes about this demo. I had to prepare my cluster beforehand, but don't worry. I'm going to share a link at the end of this presentation that will show you how to create the demo from scratch and just type every command that I type in at the moment. The demo uses star application, which shows you 3 pods that can talk with each other in both directions. And our target is to only allow client to talk to front end and front end to talk to the back end. Now, in order to do this, as the title of our conversation suggested, we could use Kubernetes network policies. Now, if I use a deny policy, which just says in this API version, use this namespace and affect every pod that sends a traffic. In a matter of seconds, you should see a gray screen because we forgot to allow the management UI, which we are browsing at the moment, peek into the traffic. All right, now it's better. So at the moment, all these pods are isolated. Now, there is a problem, I guess, with Kubernetes way of isolating resources. If you come to the cluster and use one of these pods, I'm going to use the client pod and issue a ping to a resource outside of your cluster, you will see that it can communicate with that resource. Now, this is because Kubernetes policies are affecting a namespace, and they cannot affect an outside entity unless you fancy writing every IP address in the internet in your policy. So what we could do is we could delete both default denies that we entered and use Calico global network policy. Now, when you use a Calico global network policy, it affects everything from namespace to non-namespace resources. So without worrying about every namespace that will come or be created later, you can pretty much isolate every workloads in your cluster. All right, so let's get back to the slides. Okay. Now, I talked about the isolation. In this picture, if you look at the Kubernetes environment, you can see we have a pod, container, and Ethernet. The Kubernetes network policy can only affect the pod, but Calico network policy can affect every workloads, which means containers, Ethernet networking cards, different resources that come from BGP or your routing protocol or encapsulation tunnels. Calico offers two types of security policy manifests, similar to Kubernetes network policy. We have Calico network policy, which can affect resources in a single namespace. However, with Calico network policy, you have a range of logical operators and advanced selectors that allow you to extend what could not be matched by an ordinary Kubernetes network policy. The other type of policy is called a global network policy, which I just used in the demo. And as the name hints, these type of policy are not bound to a namespace and can affect the whole of the cluster. Great thing about Calico policies is that they can be in correlation with Kubernetes policies. So you don't need to set your old policies on fire just because you want to use Calico. This is an example of global network policy. And as you can see, there is no namespace and there is a selector of all that you can use to affect both namespaced and non-namespaced resources. Now let's go back to the demo. All right, so I used a global network policy. Let's see what happened. If we go back to the same pod and issue a ping, it will not be successful because, as I said, we have a global policy that is going to deny everything that is going to talk with other resources that are not allowed. This policy has some exceptions, which I have just put in there because I actually completed this demo in like 5-10 minutes ago, and I had to just put some exception there to be sure this thing can work. Now, the next thing that I want to demo is how to use shift left and the concept of it to add communication between these pods. And with that, we're going to go back to the demo. Sorry, to the presentation. All right, so shift left. Security policies are usually the thing that you have to do at the end of development. And don't worry about it until the next zero-day exploit is revealed. Shift left will help you to move security earlier in the development process and engages other teams to suggest the best rule for their own applications. Personally, I like a shift left approach because if something goes wrong, I can find the developers who knows how to fix it, and which leaves me time for join meetups. All right, so let's go back to the cluster and use shift left. Now, first, I'm going to create a security namespace. This is because at the moment, I'm going to use Kubernetes RBAC. Kubernetes RBAC is a method to authorize resources that can access the API server. And I'm going to associate a service account to that namespace. And I'm going to get the secret of that service account, get the token for that service account, and get the CA and the API server IP address of my cluster. Then I'm going to get the CA certificate from the cluster API server, and I'm going to combine all of these to create a cluster inside my kubeconfig file. Then I'm going to set the credential for my security member user with the token that I just created. And I'm going to create a context. Now, everything I did to this point with the security, it was just to create a kubectl context that would allow me to run commands as another person, instead of running everything as the admin of the cluster. And now if I run a command with the context security context, it will show you that the user is system service account security member. Now, at the moment, this user doesn't have any kind of permission. So I'm going to add cluster role and cluster binder to give this user some authorizations. Now, the authorizations that I want to give this user is inside the API groups Project Calico. I want this user or this group to be able to affect network policies by issuing get, list, create, update, delete, and patch, which means everyone who is a member of security team can do pretty much everything in the context of security policies for Calico. The next rule that I want to add is networking gates IO API groups, which is standard Kubernetes network policies. Again, I want this security users to be able to do everything in that context as well. After I have created my RBAC roles, then I need to associate it with the groups that I want to have them. So I create a cluster role binding and mention I want this group, which we saw here when kubectl gave us a warning. So basically I'm saying everyone in that group is bind to the cluster role security case, which is full permission on this API group. Same thing for the Calico role. Now, after this, if I use the context and run the same commands, you will see everything works and I can see the network policies. All right, so this gives me a security team, and my security team can write policies for this cluster. Now, let's say security team goes and adds policies that allows backend to the frontend and frontend to the backend and client to the frontend. Now, if I refresh this page, you can see the client can talk to the frontend and frontend can talk to the backend. And in between, nobody else can talk because these are the things that we explicitly said that needs to happen. Now, development environment or production environment is not just one team that you can have. It would be great if it was, but you also need other people that work on other kind of project and applications. So I'm going to create stars member who are participant or team members of namespace stars. Again, same thing. I'm going to get the secret for that group, write the API server IP address, get the certificate from the server, run the create a cluster set for the API server and CA that I exported, export the token for the user, and set a user with the name stars member with that token, and build a context to allow me to write, to execute commands with the stars member identity. Again, I'm going to create a role and a binder. However, this time, stars team can only run, can only write stuff in their own namespace, and they only have access to the networking case IO, which means they are only allowed to create Kubernetes policies. Now, if I create this role binding, you will see when I try to create a default deny in the client namespace, kubectl will tell me, you are forbidden. And if I try to create another policy, but this time inside of the namespace stars, it will allow me to create. Now, there's one more thing that I like to point out. Now, in this policy, I've added selector that will allow backend to talk to the client on port 6379. Now, if you look at the Stars UI, nothing will happen. This is because there is an order to the Kubernetes to the Calico policies that you can use in order to make your policies like a sandwich and make sure if somebody by mistake opens or exposes a port, nothing will happen for your cluster. Now, all right, so now this image will make more sense. As you can see, the security team will be in charge of the cluster as a whole, and each developer team will manage their own namespaces by using Kubernetes network policies. And whenever they do something that is not allowed explicitly by the global network policy that you have set as the deny all rule, it will need your permission to be allowed to go out of your cluster or in your cluster. All right, so as I promised, if you like to create the demo and take it for a spin, use the link at the top of this slide. Hopefully I can manage to copy paste it. Yeah. If something goes wrong, I'm reachable at these social places and Calico users Slack written at the bottom of this page. These are the resources that I used for this presentation. So everything is written in these pages, and I would say these are the best place that you can find more stuff about this kind of concept. If you are a big fan of free stuff like me, make sure to grab your copy of Kubernetes Security and Observability ebook from our website, tigera.io. It describes the key concepts, the best strategy and technology choices available to support your environment. And thank you.
Thank you very much, Reza.
Good job. Good job.
Thank you.
Right, do we have any questions?
I do. I raised my hand. So you talked to, sorry, I missed the first few minutes of your presentation. I'm working with technology called Service Mesh and OPA, and I'm just wondering, OPA, Open Policy Agent, and so Calico does its, shall I say, protection on L4, is that correct? Layer 4?
Yes, layer 3 and 4.
Oh, 3 as well, okay. So if we want to write a very complex policy, like using Open Policies Agent or something, can we do it?
All right, so I have not much experience with OPA. However, if what you want to do is something that uses labels, it's 100% possible. If it doesn't use labels, I would say it's 99% possible.
Okay.
Again, as I said, I don't know much about OPA. Please reach me in a Slack and I can find people who know more that can help you with it.
No problem. Thank you.
Thank you.
Anyone else with a question? It's all quiet, Reza.
All right. So I took the time to open up Open Policy Agent, and it seems like it uses an API version. So I would say it is 99% possible to use it with Calico, because when the traffic comes in, it's actually a resource, an endpoint, and you should be able to manipulate it with Calico.
I see. So so Calico is on the layer 3.4. Do you know what layer emission controllers are for Kubernetes? Standard emission controllers.
Not off the top of my head.
Okay.
But if you want to go on higher levels, like level 7,
yeah,
you can also add Istio to Calico.
Oh, okay. Yeah. Yeah. Unfortunately, I'm using EKS Fargate, and EKS Fargate doesn't allow for any type of service meshes, except for app mesh, which is made by Amazon.
Oh, no.
So yeah, there's 2 flavors of EKS. One's Fargate, one's EC2. The Fargate version does not allow for any service mesh at all, and I was very disappointed.
Andre, seems like nobody else got a question. Hopefully everybody knows how to do these kind of stuff.
I guess they're gonna build their own with your instructions there. So seeing that it's quiet, Reza, thank you very much for demystifying Calico. I'd also like to take this opportunity just to give everybody a gentle reminder to let us know if you have topics to present and to help us deliver content and learnings for all your DevOps needs by completing our quick meetup survey, which I'll put into the chat again. With that, I'd like to thank you for your candid feedback and for joining us in today's meetup. Again, thank you very much, Laura and Reza, for presenting Calico. And other than that, have a great evening and rest of the week, and see you in March.
Thank you. Bye.
Thank you.
Thank you.
Thank you, everyone. Great meeting you.